students. Welcome to Experienced Tutor YouTube channel. Today we'll discuss few problems from IIT Physics. These are very conceptual problems. Please watch the video very carefully and pause it when it is required. But don't skip any method, any steps. And we are going to start with electric charge and fields part 2, and here is our welcome message. Before we start with our problem, with our discussion, we request you to subscribe, like and share our channel. Please click on the subscribe button to support us, and also click on the bell icon so that you can get an automatic notification whenever a new video is uploaded. Let us begin with the problem. So our problem is an alpha, an alpha particle has mass m is equal to 6.64 into 10 to the power minus 27 kg and charge q is equal to plus 2e, which is equal to 3.2 into 10 to the power minus 19 coulomb. The ratio of the electrical repulsion between two alpha particles with that of gravitational attraction between them is A 3.1 into 10 to the power minus 35, B 3.1 into 10 to the power minus 19, C 3.1 into 10 to the power 35, and D 3.1 into 10 to the power 37. So this is the problem. Now we'll work on the solution. So first we'll try to draw the picture. So this is one alpha particle and this is another alpha particle. So the distance between these two alpha particles is r, and the repulsion force is electrostatic force of repulsion is working in this direction. Gravitational force of attraction Fg is working in this direction. Similarly with this, gravitational force of attraction is working in this direction, and Fe, the electrostatic force of repulsion, is working in the opposite direction. And few variables are given. Charge is given, that is 3.2 into 10 to the power minus 19 coulomb, and mass is given, that is 6.64 into 10 to the power minus 27 kg. So this is the structure of the sum. Now we will resolve the sum. Next step to the sum is the resolution part. So we know by Coulomb's law it is Fe is equal to 1 by 4 pi epsilon naught q square upon r square, and fg is equal to g m square upon r square. Therefore, we can write, to find out the ratio between Fe and Fg, we can write 1 by 4 pi epsilon naught G q square by m square. R square and r square were cancelled. So this much left. Now putting the values. If we put the values, we know that 1 by 4 pi epsilon naught value is 9.0 into 10 to the power 9 Newton meter square coulomb square up, upon, we know the value of G, capital G, universal gravitational constant, is 6.67 into 10 to the power minus 11 Newton meter square per kg square. We know the value of Q is given, that is 3.2 into 10 to the power minus 19 coulomb whole square upon mass, value of mass is given 6.64 into 10 to the power minus 27 kg whole square. If we solve it, we can get 3.1 into 10 to the power 35. This as a answer. Now let us check if this option is given. So yes, this option is given to us, and the correct option is 3. This is the right answer. Let us move to the next problem. 2-point charges are located on x-axis of, of a coordinate system. Q1 is equal to 1.0 n column n coulomb is at x is equal to plus 2.0 centimeter, and Q2 is equal to minus 3.0 n coulomb is at x is equal to plus 4.0 centimeter. What is the total electric force extracted by Q1 and Q2 on a third charge Q3 5.0 in coulomb and at x is equal to 0? Options are A minus 28 microcoulomb, B 28 microcoulomb. A Option A is minus 28 microcoulomb I, unit vector I. Option B is 28 microcoulomb, unit vector I. Option C is 28 microcoulomb, unit vector J, and option D is 28 microcoulomb micronewton, unit vector K. So all are micronewton because we are finding out the force. So let us solve this. First of all, we'll make a diagram. to understand the problem. So let let this be the coordinate axis, and q1 is placed here. So q1 is placed here and q2 is placed here. q1 is positive charge, so its distance from the origin, and one more q3 is placed here. So this is also positive. So this is origin O, this is q3, q3, this is q1, and this is q2. This is negative charge. So distance from this is 2 centimeter. Distance from this is 4 centimeter. Q3's value is 5.0 nanocoulomb. Q1's value is 10, not 10, 1.1 nanocoulomb, and Q2's value is minus 3 NC. So this is the diagram. So if we draw the free body diagram for the force, then we'll get F2 is working this side, F1 is working this side. Here it is Q3, and origin. Now let us solve the sum. So from the diagram we can see that Q1 and Q2 have different charges. One is plus and one is minus, so they will be attracted. So F1 and again Q1 and Q3 have similar charges, so there will be a repulsion, and Q2 and Q3 have separate charges, dissimilar charges, therefore there will be attraction. So we can write F1 on F3 is in minus x direction. So F1 on F3. So F1 on 3 will be minus x. axis, and F2 on 3, F2 on 3 will be F2 is negative, F3 is positive. So F3 is positive, F2 is negative. It will be attraction. So its direction will be plus x-axis. So we can write F1 on F3. What is the force? 1 by 4 pi epsilon naught Q1 Q2 upon R square. R is 1, 3. Distance between Q1 and Q3. So putting these values, we get 9.0 into 10 to the power minus 10 to the power 9, 10 to the power 9 Newton meter square upon Coulomb square. Multiply by Q1 is 1 into 10 to the power minus 19 minus 9 C, and other one is 5 into 10 to the power minus 9 C upon ra the radius, the distance R is 0.02 meter square, 0.02 meter square. Now if we solve this, we'll get 1.12 into 10 to the power minus 4 Newton, which is equal to 112 micro Newton. Now in the same way, we can find out F2 on 3 is equal to 1 by 4 pi epsilon naught Q2 Q3 upon R square. Put the values, and on putting the values and solving, we get 2 on 3 is 84 micro Newton. Therefore, we have F1 on 3 is equal to 112 micronewton, negative x direction. So we can write the same as minus 112 micronewton unit vector I. And the same we can write 2 on 3 is equal to 84 micro 84 micrometer micronewton. 84 micronewton, which is equal to, in the positive x direction, which is equal to 84 micronewton I. Therefore, the net force on Q3 is F3 F1 on 3 plus F2 on 3, which is equal to minus 112 micronewton plus 84 micronewton. Unit vector I, unit vector I. So on solving, we get minus 28 micronewton unit vector I. Now let us check the options available. So options, out of the given options, we have A as a correct choice, minus 28 micronewton. And this is the end of today's topic. Please follow up our channel. Every day you will have new problems for IIT, physics, chemistry, and mathematics. Please subscribe, like, and share our channel. Please click on subscribe button to support us, and also click on the bell icon to get automatic notification whenever a new video is uploaded. Thank you for watching our videos. Keep watching. Thank you very much.